Good morning, students. Let us continue with your topic three-dimensional geometry. Students, today I am going to start with the plane. In the plane, we will discuss 3 points. Number one, that is the equation of a plane in the normal form. Number two, it passes through a point and is perpendicular to the given direction. Number three, it passes through three given non-collinear point. These three concepts we will discuss here in the plane. So let us start with the number one, that is the equation of the plane in the normal form. So here, student, ON is the normal and N is the unit vector that is along ON. Then ON, that is equal to, this ON is represented by D n unit vector. And students, let us P be any point on the plane. P be any point on the plane. Then here, this NP, this is perpendicular to ON. This is NP, student, this is perpendicular to ON. Therefore, NP dot product with the ON, that will come as equal to 0, or here this NP, we know that this is equal to R vector minus D n unit vector by using the triangular law. Here we are using the triangular law. This result we will get. So therefore, we will put these values here, that is NP vector dot product with ON vector. So it will come as R vector minus D n unit vector dot product with D n unit vector, that is equal to 0. So students, you know that this D is the distance, it is not equal to 0. Therefore, here I have written that D is not equal to 0. So you will get R vector minus D n unit vector dot product with the n unit vector, that is equal to 0. Now while you will multiply them, it will come, and you know n unit vector multiplied by n unit vector, that is always equal to 1. Therefore, what you will get? You will get D is equal to R vector n unit vector. Here is the unit vector, students. So this vector form, this is the vector form of the equation of the plane. Now what is the Cartesian form? Let us see, students. This is here what you will say, this is the position vector R. It is represented by xi cap plus yj cap plus zk cap. Here is n is the unit vector, that is li cap plus mj cap plus nk cap. So that is equal to D. So we will get, that is Lx plus My plus Nz, that is equal to D. This is the Cartesian equation of the plane in the normal form. Clear, students? Now after that, we are going to discuss with the equation of the plane perpendicular to the given vector and passing through the given point. So this is represent directly. I am going to tell you the formula, that R vector minus A vector dot product with the n vector, that is equal to 0. This is the vector equation of the plane, and its Cartesian form is A into x minus x1 plus b into y minus y1 plus c into z minus z1, that is equal to 0. Now students, let us come with the equation of the plane passing through the three non-collinear points. Here these A, B, C, these are the position vectors, and here the formula is to represent it, that is R vector minus A vector inside the bracket multiplied by B vector minus A vector cross product with C vector minus A vector, that is equal to 0. This is the vector form, students, and its Cartesian form is the Cartesian form. Here you can see that this is x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1, that is equal to 0. So this is the Cartesian form, students, right? Now after that, let us come with the intercept form of the equation in the plane. So in the intercept form, students, let us we have one of the equation of the plane, that is ax plus by plus cz that is plus d that is equal to 0, where d is not equal to 0. So students, in the first case, you know that let the plane makes the intercept at a, b and c on x-axis, y-axis and z-axis. So here the intercept at the point x-axis, that is equal to a 0 0, at point q, that is equal to 0, b 0, and at point r along z-axis, that is equal to 0 0 c. So here on the x-axis, that it will come as equal to a small a plus d, that is equal to 0, and here a is equal to minus d by a. With the same way, we will find out a, b and c, and we will put all these values here in the number 1 equation. Then students, this will come as equal to x upon a plus y upon b plus z upon c, that is equal to 1. This is the equation of the plane in the intercept form. This is the equation of the plane in the intercept form. This is very important, students, and we will make the use of this intercept form of the equation in the plane while we will discuss the exercise questions. Now let us see, students, what is the formula to find out the plane passing through the intersection of the two plane. This two plane as given, that is r vector dot into n1 vector plus lambda n2 vector. This is equal to d1 plus lambda d2. This is the vector form, students, and its Cartesian form is a1x plus b1 by plus c1z minus d1 plus lambda into, this is a2x plus b2 by plus c2z minus d2, that is equal to 0. And here is also one of the very important concept, that is coplanarity of the two lines. Here, students, this r vector, that is equal to a1 plus lambda b1 vector, and r vector, that is equal to a2 vector plus mu b2 vector. These are the two lines, and the line 1 is passing through the point A with the position vector a1 and parallel to b1, and the line 2 is passing through the point B with the position vector a2 and parallel to b2. Then, students, the lines are coplanar if and only if this condition will come, that is equal to AB, its dot product with the cross product of b1 vector cross product with b2 vector, that is equal to 0, or a2 vector minus a1 vector dot product with the cross product of b1 and b2, that is equal to 0. So if this condition it will satisfy, then we will say that the lines are coplanar, and its Cartesian form is there, that is x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2, that is equal to 0 here, students. So this is the coplanarity of the two lines, and remember, students, these NCERT concepts, they are very important, and we will make the use of these formula in the exercise questions.